And okay, recording started. All right. According to my schedule here, I just wanted to mention a couple of things which I haven't mentioned the last time. I actually I was talking about many things and just lost track of these two topics, which I would like to talk about a little bit in detail. So I would like to talk to you about lowering and what lowering is about. So one of the stages of the compiler, which I've talked about the last time, what the compiler does, it just takes your code and rewrites it in a smarter or more efficient way. And it's one of the reasons why sometimes, when you actually debug things, you will know why for example, they take a certain behavior, because right now you know what the compiler does. So for example, you do something and then you get an interesting side effect. And that side effect is because it's actually by design. So you need to be careful what are you doing, basically speaking, when you're writing code. And one of the things which you can explore is how C# rewrites your code, which actually gets this lowering phase. We're going to touch on that, I think, somewhere in the middle of the semester when we go into asynchronous programming. I will actually open the same thing again, so you can see it for yourselves. So what am I actually talking about? That's the good question, right? So the idea here is, if you take a for loop, for example. So for int I is less than 10, and then you go here and say console.writeLine, and then right here you just put ni, for example. So what happens here is that the compiler will actually rewrite this in a different way. Can somebody give me a suggestion for what is going to be like? Can you rewrite a for loop into something else? Use the same idea of looping, but write it in a different way. What would be the tool that you would use? If I ask you not to use a for loop, but do looping, what would you do?
While loop.
Use while.
Use while loops, exactly. So practically speaking, you can actually rewrite this as var x equals to 0, and then while x is less than 10, you're going to have here x plus plus, and then you're going to have here console.writeLine x. And this is, practically speaking, this is equivalent to this, right? It's almost the same thing. So we can say that the for loop is quote-unquote synthetic sugar, quote-unquote, synthetic sugar to a while loop. It's a fancy way to write a while loop. Can somebody suggest to me how you can rewrite a while loop? If you haven't done that before yet, I will not actually write the code here because I need to enable certain things in C#, but basically speaking, you can actually write a while loop as a go-to statement. Go-to statements, you see them in assembly a lot. Not only the assembly of the intermediate language, but you can see it as well in the assembly, not recursion. Recursion is something else. Recursion right now, you're going to use the stack. But actually, yeah, I mean, cool that you brought that up. And actually, what's happening is in real life is that your for eaches and your while statements, whatever loop you have, is actually the compiler rewrites it as a go-to statement. And if you want to see this, I can actually go here into roslyn.io. Actually, the Roslyn compiler is available for you as an open source, so you can actually look at how C# is being done or made. So Roslyn compiler git, and let me grab this and push it right there. So if you actually go here, you can see the source code of Roslyn compiler, like how the compiler is actually compiling your code, right? So CSC, and then I don't know, I'm just clicking everywhere around. So this is like how C# compiler might look to you from the inside, but obviously I think I'm actually in the wrong project, probably. Portable, then you have lowering, you see? And right now you have something which is called local rewriters. And then within the local rewriter, you can actually have fun. Right now this is on GitHub, but I can actually do it as well here. This is someone actually have written an interesting way, like a web application that does look at the code, source code like this, so you can actually expand it like as if you are on Visual Studio, right? So you can have this ability to look at your compiler in that way. Unfortunately, right now I actually got lost for a second. I don't know where are my local rewriters though. Code style, code analysis, C#, lowering, local rewriters, and then you can actually look at your rewriters. So for example, you can have a look at how your conditional access, so how your actually if statements, I think, are being rewritten, if I'm not mistaken, like how your if statements will be lowered, how, for example, if you would like to look at your for loop, here you go, here's your for statement. So your for loops are actually boiled down into a goto statement. This is just an explanation how the goto statement will be done. And this is like the emitter, which the code rewriter code here, it's just abstracted. You will not see that much unless you dig in how this code rewriter will work. But practically speaking, it just boils down to a goto statement. Here's your while loop, actually. While statement. It's also, again, it's going to be rewritten as a goto statement. Okay. Now, obviously, you can read in how each one of those guys are being just implemented from the inside until you reach there, right? So assert, return, rewritten. Yeah, you need to probably dig in a little bit much deeper until you see the IL generation bit. But in any case, this is the part of the compiler where it just simply keeps rewriting your code in a different way, which is valuable thing to know about. Another thing which I wanted to mention is the garbage collection. Now, the garbage collector, what it does is actually, first of all, let me give you the link. Whoop, sorry, wrong keyboard. Garbage collection C#, and I need the MSDN. I need the MSDN page because there's this beautiful documentation by Microsoft. I think it's the best. I'll give me a minute. Let me find just the page. MSDN. There's this main page which links to multiple other pages. So there you go. This, I'm just going to paste it in the chat. There you go. This is your, this is the web page from MSDN that you actually need to read, and I advise you, really advise you to read. And you read them like in that specific order. I think it's actually good. And I'm just selecting the fundamentals of garbage collection here. It's about like how you are actually reserving memory, because there are actually three garbage collectors. Oh, sorry, three stages to the garbage collector. So you have like the generation 0, generation 1, and generation 2. And then it will describe to you when it will release the memory at which stage. And for example, like if you have a short-lived objects that are not going to be referenced from anywhere. So for example, if you are having something like static void something, and then you define, let's say here, I'm going to have a class person, and which has a prop, which has a string name, for example. And then, by the way, I triggered this by saying prop and then tap, tap. You have a prop full, which is tap, tap. It gives you the full property, like these interesting code snippets. So it makes you work faster. And right here, you could have, for example, you could define a person, var p equals to new person. And if, for example, I'm just saying this for example, so if the compiler or if the runtime, common language runtime, sees that this person will never go outside of the scope, so it will, once it reaches here, it will be collected as early as possible, so it stays in generation 0, it doesn't go deeper and deeper. The more you reference this, like the more this guy lives on, let's say by, for example, you return a person right now. So if you return this, so return p, right now it cannot get rid of it unless we lose a reference on it, for example, right? So you don't actually save that reference. If you save that reference, it will live on, so it will not be collected by the time you leave, for instance. It is one of these interesting compiler optimization that the compiler does for you. If you are actually working even with Java people, there's a concept. So Java doesn't have value types like in C#. So we have value types which are allocated on the stack. These guys are allocated on the heap. So reference types are allocated on the heap, and we are saying it is that way for the sake of the argument because we are still beginning on this thing. There is in Java something which is called escape analysis, which if it sees that this object, if it doesn't escape or it doesn't get out of the scope, it will be allocated on the stack. But this is what Java does. I don't know if C# does certain optimizations like these. I don't know, but it's probably possible. But we have already value types and reference types, so they probably get this still allocated in the heap. I think we need to dig a little bit more into the compiler and see this. But I'm just giving you the full story here. So not to confuse you or anything, the garbage collector will collect this maybe if we are, by the end of the scope, if we are doing something like this. Okay, so you've done something to that person, or you change its name, so name equals to X, for example, and that's pretty much it. Right now, you've done whatever changes you've done, and then you close the braces, and that's it. If this person object is not referenced anywhere, it will be just simply collected at a certain time. So that's one of the things which I wanted to mention about the garbage collection. But this is a very, very short story. I advise that you read that documentation which I've sent. It is super important that you read it. It's like, if you want to become a C# developer, you really need to explore this and read this very thoroughly. All right, so now that's out of the way. Let's talk about constants and read-onlys, and I'm gonna actually give the same. I'm gonna give the same topic or the same examples, which I was giving during the class. The constants in general. So let's talk about this one. So let's say I actually was I'm a space fanatic. I like about anything about space and stuff, and I was actually giving examples from this kind of field, astronomy, wherever you would like to call it. So if I have something like a math constants class, so you can define a constant based on, like, okay, not based on anything, but let's say, okay, so let's say they have a public constant float, and we're going to keep it float pi equals to 3.1415 f. And you have to write f, because if you don't write f, C# will think it's a double, and it cannot convert double to float, so you need to specify literally by f. A double should be, I think, d, and decimal should be m. But we're gonna get to that later. F. Right now we need f. Constants are static by default. Okay, so you don't need to write. If you write static, it's unnecessary. because constants are actually static. So if you go into math, constants dot, you will get actually pi right away. You didn't need to instantiate an object of math constants so you can get to it. So constants are by default static. And static members of a class, they belong to the class and they don't belong to the object. Okay, so that's a very, very important point to mention here. Also, you cannot change them. So if you have, for example, something like, you cannot actually go ahead and say, okay, math constants dot pi equals to 10, for example. You cannot do that. The compiler will not allow you. In fact, if the compiler sees a constant, it will not even allocate anything on the stack. It will go ahead into your code and literally replace anything that has pi in it with that number, because there's no need to allocate something in the memory because if it's a constant, right? It's going to be there as long as the program actually lives, right? It will never change. So it will literally like flip out everything. Now, it's a very important thing that to mention here. This is resolved or determined in compile time. During compilation, this is being processed, this is being understood, okay? So what is the difference between this and read-only then, right? So let's say that you would like to have a planet. And every planet is actually kind of different when it comes to gravitational pull. So I don't know, like if you look at the gravity of, let's say, let me just search here really quick. I never searched this during the classes, but hey, planet gravity, gravitation list, solar system, our current solar system. Let's see if it will actually give us something. I need some sort of a, like a comparison, like how many times or even the mass. I mean, it's fine, like everything is fine. So if I actually grab this is from Wikipedia, gravitationally round objects of the solar system. So the sun has this mean radius, has the surface area, volume, mass. So 10 times 1.9855 times 10 to the power of 30, which is fun. I mean, when you look at it, most of these planets are like spherical, quote unquote spherical, or they are round objects, but they have different properties every time. But once you actually instantiate a planet, its property doesn't change, unless a huge catastrophe happens, which hopefully nothing happens, but you get the idea. So, oh, there you go, equatorial gravity. So let's see. So Venus is having 8.87, Earth is 9.7, Mars is much lighter. However, Jupiter is 24, which is way, way, way more powerful than our Earth. It's like what? 2, 3, almost 3 times. So actually, yeah, 2.5 or something like that. So let's say that you would like to create a planet. So what you're going to do, you would like to have a configurable gravitational power. However, you don't want that gravitational power to change after the planet has been instantiated. Once the planet exists in the solar system, that's it. You will not change the gravitational pull anymore. It will not be dynamic. So what you're going to do is you can define something like float, public, read-only, float, gravity or gravitational power, or whatever, right? And by the way, they are actually fields. They are not properties. You cannot do this. So read-only and constants, or constants can be properties, I think, or my knowledge, nope, they can't. So yeah, constants are like the same as fields. The constant and read-onlys are fields. They cannot be properties. It will not allow it. And then here we're gonna have a Seator planet. Then right now we can have a float So when you instantiate a planet, you can say what gravity is going to be equals to gravity. And this guy can be modified only within a constructor. So once you instantiate the object, you modify it in the constructor, and this is it. You cannot modify it anywhere else, not within the class. So if you have, for example, like private void modify gravity, for example, you cannot actually have something like gravity equals to 10. You cannot do that. It will not allow you to do that, right? But it will allow you to do this only. So if you have a var p equals to new planet, and then you say it will take a gravity of 9.81 F, let's say, approximately. So this is Earth right now. Let me call it Earth. Okay, so right now you cannot say, you say Earth dot, and then you can gravity, and it says read only. So you cannot do this even. So you cannot do, it will not allow you to do this. Okay. This is like the difference between read only and constant. This one resolved in runtime. Or these are the differences. Resolved in compile time, resolved in runtime. This is the things which you like. I know that this is a constant, but it has to be set once the object is running, and this is a universal constant. This never changes, right? You might add later on the additional decimals which you are missing, but the pi never changes, right? It will be always the same as long as we are using this Euclidean mathematics and we are not breaking any universal rules, or the universe didn't change all of a sudden to something else. So let's call it that way. Okay. Does this make any sense?
Yes.
Yes, it does.
Okay. Any questions so far?
No.
Okay. Glad that it's actually clear. Let me see. Okay, let's talk about inheritance. Now, inheritance is actually relatively easy because you guys already had it in the last time, last time with in C++ with Dennis, and I think you should be already well trained for it. But let me show you the syntax for it. So. Let's talk about, like, I'm going to make a grave scientific mistake here, but just to drive the point across. So public class dwarf planets. And I think anybody who sees this doing astronomy, probably they will kill me, but we are learning. Inherits from a planet. Okay. Oh yeah, right. I need just for the sake of the to make it just a little bit easier for us, so we don't complicate our code. I'll just simply write there a default constructor. Okay. So because otherwise I had to write a constructor that takes a float gravity, I think. And right now this will be legal, where you can actually say, I think you should be saying here base dot. Although actually you can do this base of gravity. Do you know what does this mean?
Yeah, the inheritance class constructor is called.
Mm-hmm. So you're gonna call the parent class constructor to construct based on the gravity which you pass in here. Okay. So this is like you're just, yeah, you're not recycling, but you're doing like what you should regarding the calling the constructor. So you don't need to construct this again by hand. You just simply call whatever you call, and then you can push additional stuff. So right now you can have add here like int order in solar system, like in which place it is in the system. Okay, is it like the third planet, the fourth planet, the sixth planet, and so on and so forth? I'm just adding something random here. This should be actually in the planet, but you get the idea. Okay, so this is basically inheritance. Nothing fancy. You already have seen this before. But what you can do though is you can start overriding stuff, and you would like to, if you would like to override a function or a method in to make a method overridable, you need to mark it as virtual void orbit, and then you can actually say which star it orbits around. So here, for example, we can have a another public class star. So here, public string name, get and set. And then you have here a public, I don't know what, float mass equals to get and set. Right, so you can do that. And the right here, it just simply takes a star. So for example, here, star. And by default, we're saying that the, for example, we say public star, or actually, no, we will keep it that way. Actually, yeah, actually we can, so, yeah, fine, we can say star orbiting star, whatever. I mean, I'm naming it badly, but you get the idea. This can be in the constructor as well, but you can actually modify some interesting things here. So equals to star. And then you can write in more behavior. So behavior of orbit. So we can have here, for example, maybe it's going to be having a circular orbit, elliptic orbit. So elliptic orbit. It depends really on how you would like your planet to orbit the star. And actually, I can actually even remove this. There's no need for it. Here, you just simply define the. Yeah, we can say, okay, how about this? I'm sorry, I'm just writing this live. So, console.writeLine. Sorry, console.writeLine. And here, I'm just going to have here elliptic. Okay. So let's say that we have by default any planets we instantiate is just elliptic. But then suddenly, all of a sudden, you are actually like having a dwarf planet that happens to be all the dwarf planets in your system. They happen to be having a circular orbit. So what you can do, you just simply say, okay, all my dwarf planets in that system are going to be circular. What you can do is just simply say override, and then you have orbit. And right here, you can either call the base orbit, or you can actually call the console.writeLine, for example, and then you say, okay, my orbit is actually circular orbit. Okay. So this is like when you're going to do virtual, like you provide a default implementation, and then if you don't like the default implementation, you can just simply override it with something else. The toString method, this star, this like if you have, for example, override this to string, get hash code and equals, all of these guys are actually virtual methods in the object class in C#. Okay, so that's that. Does this make sense?
Yeah.
Yes.
Yeah. Yes, it does.
Okay. Good. Now that's the virtual bit out of the way. Let's see. Let's talk about abstract classes right now. Oh, by the way, before I forget, so if you have one more thing, public void orbiting moon. So what kind of moon is orbiting that thing, let's say? You cannot override it because it's not virtual. So public virtual, public override. You will never have it in the list, right? and the orbit is not in the list because the IntelliSense is smart is saying, yeah, you already implemented it, but right now you cannot override this. In order to make this overridable, you just have to have a virtual on it. And right now, it will appear. Okay. Now that's out of the way. Let's talk about abstract classes. And abstract classes are actually quite interesting. It's actually quite interesting topic because of its applications, actually. My question here for you is, can somebody give me an example? Not an example. Let's say, first of all, what are abstract classes? Can somebody give me just a quick explanation? Accuracy is fine.
Classes that cannot be instantiated.
Classes cannot be instantiated. Okay, anybody else? This is one of its properties, but what else?
Abstract classes can be used as a base class, so you can't make instances of it, but it can be a reference or a pointer. And the derived class can be, derived class can have the abstract base class as its parent class.
So to summarize this, so you wanted to say that the abstract classes are there, you cannot instantiate any objects out of them, as Haris said, and then you said that we actually need to inherit from them in order for them to be useful, which is actually true. Now, when would you actually use an abstract class? This is actually an interesting question right now. When I will make this design decision, and I say, okay, this is a very good time to use abstract classes. Can somebody give me an example?
If you don't want instances of the base class, for example, if you have student, professor, assistant, and you don't want an instance of a base class person, then you put it as an abstract class.
So if you would like to have a more defined concept in your application, so you don't want to have you don't want to instantiate a parent class, you would always instantiate a person or a student or a professor. From the design standing point of view, you could actually use abstract classes, which is okay, fine. You could say fine as an argument. Anybody else as well? Can somebody also give me a guess? I mean, by the way, all of what you guys have said is actually correct. There's also one more interesting reason why would you use abstract classes actually?
Maybe to force the other classes that inherit that base class to have certain implemented methods.
Actually, this is also true with abstract how do you call this, abstract methods. But
maybe if you want to cast the base class into a certain derivative class later on.
Well, I mean, this is you already get it up by default from inheritance. But what I wanted to say here is, you see, when you say that you would like to force the other class to inherit, to implement a certain member, this is like when you elevate the argument right now upwards and say, okay, what is the difference between interfaces and abstract classes, right? Because right now they became similar. So let me actually, all what you have said is totally fine. But let's right now make it a little bit more profound and have a shape. So let's say. All right. So honestly, I mean, theoretically speaking, everything is possible. I don't know, I think an astronomer or an astrophysicist might actually disagree for sure about what I'm about to say, but actually there are, you know that in the universe we have rogue planets that do not have a star. They just simply probably the stars have exploded a long time ago and they're just simply wandering around or just catapulted somewhere, or they got hit by something that just simply made them drift and get out of orbit. So practically speaking, we can say that right now these rogue planets orbit around the galaxy, quote unquote, rather than orbiting around a certain star. So they're just simply wandering around, but they are orbiting around the whole galaxy, right? So if I actually want to, I could modify the planet a little bit here. So I'm gonna just simply remove this bit and remove that bit. And right now I would like to define, let's say I'm actually creating a base class, a planet as a base class. And it's gonna be an abstract class. And right now here we have an abstract void orbit. However, there are a couple of things I would like to have. Public class ecosystem. Oh, sorry, not class. Void set ecosystem, for example. Populate ecosystem, whatever you'd like to call it. So populate. Which takes, for example, for the sake of argument, I think people will rejoice if this happened. Okay. And you could have something like this. An array of trees, right? And then right here, you can just simply say, you can write here the logic, populate the planet with trees, right? So you can have like, right now you can have a private array of trees, called trees, get and set. And then you can have, for example, trees equals to new, whatever, tree, let's say like so, and then we can have 100 trees, for example. Did I make a mistake in the... I cannot construct arrays anymore. Did I forget the syntax? I did forget the syntax. Cannot apply indexing with operation trees. Oh, come on.
Professor, your faculty staff meeting is soon to begin.
Oh yeah, right. So, okay, so let me... So, but I need just to fix this. I cannot somehow my brain farted. If you excuse me, right now I cannot see the the thing. There we go. Sorry about that. Just sometimes you get this. So right now I populated the planet with 100 trees, and afterwards, like I'm gonna give you a break because I have to jump to the faculty staff meeting. So I will jump out and I will jump back again once the meeting is over, okay? So I'll give you a break for hopefully like half an hour and then I will get back again, okay?
Okay.
And then I will carry on with the description of what I'm doing here. So see you after the break.
Okay.
Pozdravljam. I'm back. Ne znam koliko vas ostalo još. Jel vi ste tu još?
Da.
Yes, please, mom.
Dobre. Okay, perfect. Perfect. All right. Apologies again. It was a sudden meeting, and obviously this has been left recording. But hopefully you got your break. I will. I actually need to share my screen, as a matter of fact. Now I'll just close this and share my screen, which is this. So hopefully right now you can actually see my my screen right now, right?
Yeah.
Perfect. Okay. So where were we? We were actually talking about the like why we actually implement like having abstract classes, right? And I've stopped at populating the ecosystem, right? And just to recap here, I'm making the planet as an abstract class, where the orbit is an abstract method. However, the populate ecosystem is not. Okay, so I'm making this crazy assumption, and don't mind me here. I'm just saying, like, just a crazy assumption, for the sake of the example, just to make an easy example. Let's say so. Okay. I'm going to say that every planet which I'm going to create is going to have an ecosystem, a valid ecosystem. Okay. So that's what I'm actually planning to do. Now, what's going to happen is if I'm actually inheriting from a planet right now, obviously I am not able to have a constructor, the inherited constructor, or any of that stuff. But right now, if I actually take this out, right now we get an error, isn't it? So if I have actually Alt-Enter and implement the abstract class, I'm going to get it implemented correctly, right? So right now, what's happening is I'm actually forced to implement or override, if you will, override the abstract classes, the abstract method, because it's marked as abstract. Now, this actually doesn't come as a surprise for you, but if you notice something, you will see that the planet implementation has already half implementation in. So we are assuming that there are certain things which are going to happen regardless of what you do. It's one of them is populate ecosystem, and the ecosystem will be always populated, like with trees and nothing else but trees. Okay, no animals, nothing, just trees. Okay. Which actually like gives you a hint what an abstract class is for. So an abstract class, basically speaking, you're gonna actually go for that design decision. If you have, for example, like you would like to do half-baked or half implementation. So consider it like the frozen pizza, which you get from the supermarket. The frozen pizza, you cannot actually eat it directly. What you need to do is just put it in the oven to be cooked. Are you going to put it in the oven? Are you going to put it in the microwave? It actually doesn't matter. What matters is the implementation already has been done. There is part of the implementation, which is the cooking bit. How are you going to cook it, right? Which actually might be even a better example than the planet, but you get the idea, right? It just, when you know that there is a certain implementation you need to provide, however, there is a part of the implementation is up to the developer to continue to expand on to make this complete implementation. Then you start using abstract classes. Because if you look at interfaces are actually similar to abstract classes, except they don't have implementations at all. In fact, if you look at interfaces like public interface, and I'm putting it public just for the sake of clarity. Public interface I something. Right? And in I something, I can have a void some method. Okay. And if the planet implements that interface, or let it be here, because you can inherit from a class and implement an interface as well at the same time, just for fun. Okay. It is actually quite similar to the abstract classes, right? It's just once you inherit or once you implement, it's called implementing an interface. You actually have to implement everything which has been mentioned here, right? All the methods and properties and such. So right now, people will actually ask, what is the difference, right? So this is the difference, practically speaking. Interfaces, they are almost similar to abstract classes. You cannot instantiate them. You can only inherit or implement them, right? So in case of the interface, you implement an interface, and in case of an abstract class, you inherit from the abstract class. However, the abstract classes, you will go for that design choice if they actually provide to you a certain amount of implementation, and then the rest has to be defined by you, right? So you can actually start using it as it should be. If you would like to define something which is called a contract, this is right now what an interface is. Interfaces are contracts. Now, I will actually hammer more down on that idea in a second here, but what I wanted to show you is one more thing. If you noticed, I usually precede it with an I. And this is a habit we got from the C++ times. And C#, every interface in C#, when it's getting named, this is the naming convention, we put an I before it, okay? Java has this concept of interfaces. They never put the I in there, okay? But since C# is more like a super, like it's actually a successor of C++, quote unquote, you can say so. It's actually like we inherited this concept of naming with an I. And there's a very good reason. Interfaces do not exist in C++. However, abstract classes do, right? And the interesting part here is because C++ developers need to differentiate between what is an interface as a concept and abstract class as a concept, they just simply proceeded with an I. So practically speaking, what C++ people were doing, they did this. And they literally put an I in there. They needed to differentiate between classes in there. And then you're going to have like public abstract method. Okay? And that's and it's void. And that's pretty much it. And this is how C++ people did their work. And this is why you have multiple inheritance in C++ is available for you. So you can actually like bend the language and do these moves, right? Now, obviously, you can shoot yourself in the foot easily if you don't know what you are doing. If you provide some sort of default implementations in here, I mean, it's again design choice. But if you would like to keep things clean in C++, what you're doing is just like you could have, since you have multiple inheritances allowed in C++, you can actually like have several abstract classes that are basically just a bunch of contracts. C# came in and just cleaned that bit, and they just simply say, okay, you don't need to define an abstract classes, you just simply define an interface. And that's it. And if you would like to have an abstract class, please provide an implementation. You would say, okay, also it's not public, it's actually by default going to be public, but you should provide at least some sort of implementation of some stuff, and then leave the rest which you don't know how to define, leave it just for people to define it, or leave programmer B to take in the stuff and just finish it as it should be. So this is basically the point behind when you're going to use abstract classes and when you're going to use interfaces. Interfaces are, again, a long time ago it was written in MSDN. Interfaces are contracts. literally, they say interface is a contract, which if you sign that contract, and signing the contract meaning like you do this, okay, so you put the colon, and then let me actually take this out just for the sake of the argument here, and let me take this out. If you actually say I'm going to implement that interface, you have to implement the contract. If you don't do the contract, if you don't follow the contract, you are invalidating actually your code, and your code will never run. The compiler will not let you do anything. So that's the main important thing. In C#, your code can implement multiple interfaces. So you can have a public interface, something else, and then you can have it like so. An interface could happen to be without methods. And these interfaces in software engineering, they call it the marker interface. But this is just a fancy keyword for an interface which doesn't have any methods. There is a rule for it in software engineering why you would do this. Even though it is actually frowned upon sometimes practice, sometimes it's like people don't like it. They think of it as not clean way of doing things. I honestly, sometimes I used it, but in any case, it depends really on your use case when you would like to use a marker interface. In interfaces, you can do this as well. So public interface, let's say iCar, it can implement as well this. So you could have interfaces implementing other interfaces, even though they will not have any methods in them. So think of it as inheritance of some sort. So like you can think of it like void. Let me just put this in. Right now, this is not marker interface anymore. Void another method, whatever, another method which takes an int I, whatever. I mean, I'm just making things up here. And right now, if you, for some reason, you implement the iCar interface, and iCar has, for example, another method which is void drive, whatever it is, then whenever you would like to implement both of them, so you're going to have another method, you're going to have drive, okay? And I something is coming from the, oh, actually, this is, I don't know where this is coming from. It's coming from I something, okay. So right now I'm implementing two interfaces, and then planet suddenly become a car, but you get the idea, okay? So I'm just showing you the syntax and what you can do with the syntax, okay? So let's actually go to a very, very concrete example that shows you really the power of the interfaces. The concrete example is going to be much less complicated, much less complicated, but and probably even flawed at a certain point. But I think it will drive the point across. Okay, so probably if somebody saw this from the software engineering perspective, they would be like, this is not cool, dude. You could have done it in a better way. But again, we are just learning here, so code can get a little bit ugly sometimes. Later on, once you master the basics, you know the stuff, then you can write a production code. So for example, I think RSYed and RS2 we can do production code. At least in RS2 it has to be a production code because you already got used to C# and stuff, right? So okay. So I'm going to give you the same example which I've given to the class. We assume that we have a game. Let's actually talk about the requirements for a second. So let me run here MS Paint. Let's talk about the requirements for a minute. Let's assume for a second that you are making a chess game, right? And the client was requiring that you're actually having a chess game that that can work on phones. So let's say this is your phone with the with the infamous circle right there. So you have an iPhone right there. You would like to project this on a billboard in a shopping mall. So people are playing chess online, but it just projected on a shopping mall. So a shopping mall billboard, which is a specific kind of monitor that you need to write a special code for it. Think of it as e-ink displays or whatever. And then you have, for example, you would like to display this on PC in 3D. So let's say you have a nice rounded PC screen, and you have this nice monitor stand. So there you go. So this has to be in 3D. This is a billboard with light bulbs. So let's call this projection, or whatever. We can call it projector. A special projector, a special screen like the street screens, which has a specific kind of displays. And you need to write how the display will work, because let's say, for example, for the sake of the example, it's just have a special way of accessing it. And then you have the phone, which super weak from 2002 or 3. Yeah, I think back then it was 2002 or 3 that we started to see 3D stuff on phones. I can't remember anymore, honestly. It's been a long time. But I think I think we have seen 3D on phones back in 2000 and, oh, maybe even more, 4 or 5, I think. Yeah, back when Symbian was started to grab traction. But anyway, so you need to render the chess game in 3D. You do the projector thing here on the shopping mall, and you need to do. Sorry, this is not 3D. This is 2D. This is a phone. It is weak. We're gonna do 2D, and this has to be done in 3D. Okay, so you have like 1, 2, 3 ways to project stuff. Dennis actually talked to you about iLogger, how to log into database file and maybe something on the internet, right? And this is another example which just, like gives you right now 2 sides of the story. So hopefully it will drive right now the point across. So Dennis's example and this example will help you out, figure it, understand have a feeling for it. Now here's the interesting part. The problem is, you're gonna have a problem where you would like to solve this. Is right now you have a couple of choices. The most naive choice, which you shouldn't do, is to write the chess game 3 times, and you're gonna have 1 for the phone and 1 for the projector and 1 for the 3D stuff. And this is kind of a wrong way of looking at this. The second way of looking at this is that you actually program the game itself, right? So this is the game, let's say. So this is your chess game. And you would like actually to do the projection bit. So what you do is just you offload this to somebody who draws stuff, who knows how to draw the stuff. Let's say we're going to have a contractor. I'm going to call this iDrawer because rendering is going to be a little bit interesting. So we're going to call this iDrawer. And this is my contractor. And his job is, whoever implements the contract will be able to draw on 3D, on a projector, that special projector, and it's going to have the ability to do 2D as well. So if any of those contractors does their job, it will project on the screen, but the CG works with a contract, and it will not work with implementations. With interfaces, you are bound by a contract, not implementation. You don't care how the implementation happened. You care only about the contract. And the idea of a contract is super important, that you get it. You need to get it in your head, right? Interfaces are just mere contracts. Just they are written in C#, and that's pretty much it. It is the same thing like when you're going for a job, applying for a job. You sign a contract. You're going to be in the job as long as you are satisfying the contract. Once you violate the contract, you're going to be kicked out, which is normal. It is exactly the same thing with the compiler. If the compiler sees at compile time that you are not satisfying the contract, the program will never run. So let's talk about this. So let's actually try to have a chess game. So if I have a, I'm gonna actually have a public class, or a class. So let be public class chess game. Because I mean, I'm gonna keep the stuff very, very simple here, because the game and the chess, the concept of a chess with its chessboard and rules is different from the game itself. But we're gonna ignore the nice design principles here for just this case. And let's say that we have a public string, the board, okay, which is just representation, a logical representation of the board, okay? Right now it should be, let's say, an array of pieces. So if you would like to do this better, you can actually just simply have a piece, chess, piece, right? And then you can have, for example, right now, public string, which actually could be like a property of an image, or let's say string name, or piece name. So is it a pawn? Is it something, right? And then right here you can have a array of chess piece. We call it chess pieces, right? And do that, okay? And then we can carry on from there. But we would like to simplify our code, because our code will be more and more complicated. So I will not do this. I'll just simply say that we have a string and we have a board. Actually, like, the board could have been another class, but we will discuss this. Okay, because the chess game is the one which controls the rules, the board is just holding the pieces, and the chess piece is just a chess piece, right? But let's say that this is the whole board with all the chess pieces and stuff, and we would like to draw the board, right? Now, as per this diagram, it's actually not even a class diagram or anything. It's just a diagram. We know that we would like to make the chess game offload the rendering or the display of the chessboard to a constructor. So what we can do is just simply say, okay, I will have something which is public interface I drawer, and its job is to draw. That's it. This is all what it has to do. It just has to draw. What it is gonna draw? It's gonna draw a chess game. Just please draw for me the chess game. This is its job. Later on, when we learn about generics, we're gonna make this generic. But for now, it's this thing is drawer. We can call it chess game drawer, to be precise, because right now it is actually it is statically typed. Okay, and what we can do here is like, and again, this is a bad design, but just to give you, just for the sake of the argument, I'm actually gonna make the job of the chess game to draw itself, which software engineering people right now will scream at me, but for the sake of, you know, learning, let's keep it here. I'm gonna have here void draw, and it will actually take chess game drawer, which is actually kind of might be a bit confusing for you here, but just hang on with me here. And I'm gonna call here chess game drawer.draw. This is it. Draw this. That's pretty much it. This will never change. It's done. Okay. Now here's the point. This, I think you have seen it in C++. Can somebody tell me what this is? Like this keyword?
It's a pointer, and the pointer is the object that called that method.
Exactly. So this is pointing to the current instance which we are holding in our hands, right? So that's it. And right now let's talk about the implementation details. So let's say, as we wanted to say here, is right now the chess game class have successfully given the the contractor, let's say the contract, like this guy says, I'm accepting this kind of contract. Whoever subscribes to me with that contract, or whoever gives me an object that satisfies this contract, then I'm going to actually use it. Otherwise, I will ignore you, or I'm going to scream at you with a compilation error. So right now we are done with this. Let's do the phone first. So if I'm going to go here, I'm going to have a public class phone drawer. And let's say this phone drawer is going to implement my chess game drawer. By the way, I'm hitting, let me just undo this. So if I hit Alt-Enter, it will actually give me suggestions. The IntelliSense will give me suggestions. So if I hit Enter again, I will be able to do this. So right now, I can just simply say chess game dot board, and I will actually console right line this. And I will have, actually I can use interpolated strings here. Okay, I'm gonna call this the chessboard is this, okay? Hang on. Let me make it even better. 2D chessboard on phone. Let us put this here. Okay, let's do another one. Right now we have a contract, like I have a class that implemented this contract or this interface that does the drawing bit. So it takes a chess game object and it will just simply draw it in 2D. Here you write 2D logic, pixels, coloring, refreshing, screen, logic, etc. So right here you write actually a huge ass code about this stuff. Okay. So let's get another one. So let's actually talk about the projector here. That's one which actually will do the projector in the shopping mall. So what I can do here is just simply I'll do another one. Public class projector drawer. It's going to implement iChess game drawer, and I will just have the same thing, except I'll just let me copy paste this here, and I'll just simply say that this is going to be projecting in shopping mall. Okay. Here you write again. Here you write how you gonna project on that special projector, which doesn't exist in the world except for this shopping mall. It has been customly made. Okay. And let's say public class, and this is the final one, which is going to be our PC, which is going to be 3D. So I'm going to have, like, let's say 3D projection, because you cannot write number 3 actually here. In C# you are not allowed to do this. Okay, so you have to write like this, and it implements again the contract iChess game drawer. And right here I'm just gonna this, and I'm just gonna say rendering chess board in 3D. And this is like here you write 3D transformations and shaders to render everything correctly in 3D. Okay, so this is going to be the logic, the game engine, or the graphics engine, whatever. Its job is just going to take the chess game board and just, project it right away. And that's actually pretty much it. Right now we have 3 classes that implement this interface, and your chess game is just interfacing with that interface. The rest of the guys just simply implement the contract. And every contractor, or every like 2D or 3D or projection, or the projector, what they do is just simply they do their own implementation and logic for that specific screen which you like to project on. So what we can do here is we're gonna right now create another object of a chess game. Right now we need to play the game. So we're gonna have a var chess equals to new chess game, right? And the chess game gonna have a board of some sort in there. So let's actually have a let me say board equals to, and I'm gonna actually see what are the valid, because I actually tried this in the class and it didn't work. So valid ASCII characters in consoles. So I need just something that I need ASCII art. I don't know, what is this? Aha. Okay, how about this? System text dot get encoding, I think, or encoding. Right now this is live coding. I don't know what's gonna happen. Get encoding, and right now I need to provide a. Right now there are overloads for this probably, so there are actually integers and names and other stuff. So I'm just gonna give an encoding. Let me see. Do we have a chess piece that we can show? ASCII characters. ASCII characters in chess game. Chess character. Let's see if we can actually get one. It is U. It's actually UTF, not Unicode. Yeah, it's a Unicode. I think there was a way. Hang on, let's see. Can I actually do this? I really wonder. I never tried this. Yeah, it returns an encoding. Can I say dot get string? Oh boy. Yeah, okay, it's gonna be a little bit interesting to do. Let me I think there was even a conversion for this guy. So yeah, let's see what this is gonna happen. I mean, I know that it's gonna be a little bit dot to string. I don't know what's gonna happen, honestly. Just probably we're gonna go somewhere weird, but if it works, it works. If it doesn't, then fine. And then what's gonna happen here is right now this is my chessboard. It has this piece for now, and then what I'm gonna do is I need to draw this. So I need to create an object out of each one of those if I would like to draw that single chess game. So let's say I'm broadcasting live a chess game right now between two famous people, and you would like to see this in all platforms, stream it on all platforms. So what you're gonna do is you're gonna take the same chess game object and say, okay, let us render this in 3 different ways. So I'm gonna create a var phone drawer equals to new phone drawer, right? I'm gonna have another var projector. Projector drawer. And then I'm gonna have a var phone 3D drawer equals to new 3D or 3D projection. Okay, 3D projection? Fine, let it be 3D projection. Even though it should be 3D drawer, but fine. Let us be consistent. And then I can say chess, because I know that this is a bad idea, but we can say chess, draw. And right here, it accepts whoever implements that interface. So it accepts a phone drawer. I can say, okay, draw it again as a projector drawer, and please draw it again in 3D, right? It accepted 3 different objects, but the common denominator between them is that all of them, they are actually implementing the same interface. By the rules of polymorphism, it will actually pass through. So let's say I'm going to have a console.writeLine, and let me make just a nice separator so you guys don't confuse yourselves here. So Control C, and there we go. Okay. So if let's see what's going to happen. So if I give Control F5, I think. Oh, yeah, actually, I don't have ASCII coding. Hang on. Let me see. What are the special ASCII characters table? Let's see. I need something cool. Ah, there you go. We have something cool. Let's say 219. If this will actually work. Oh, actually it doesn't work. Apparently I actually screwed up some stuff. How about this? Let's see. How about this? I can. I mean, can I actually do this? Can I actually force it to be like so? Yeah, it's. Yeah, I need to make this as a thing, but this will not actually work. So let's call this as a pawn for now. Later on, probably I'm going to show you how to play with strings. It's a little bit of a long story. But let's say this is a pawn, and then you have another one like has multiple spaces, and then you have a king, let's say, or something like that, and then you have a queen. Okay, and let's hit Control F5 now. And as you can see here, 2D chessboard on a phone, projecting in shopping mall, again, the PKQ, and then the rendering chessboard in 3D. Okay, so all of this has been executed based on your interfaces. So let's actually dig down a little bit. So let's actually put an F9 here. So F9 to hit the breakpoint and hit F5. And I need actually, I know that I can do this. I just, probably the syntax is escaping me how to make this showing ASCII characters. I need to concentrate. But in any case, so right now we actually stopped right here. So we created a new class, a new object of a phone drawer, projector drawer, and a 3D projection. We have the chess game object, which has just a PKQ, right? And I will actually hit F11 to step in. And when I hit F11, it actually took me, the chess game took me to the chessboard, right? Like, sorry, the breakpoint took me or the next line, took me to the draw method within the chess game. And as you can see here, I'm implementing an interface. And it says here, if I hover over here, it says phone drawer, right? So this is the namespace dot the class name. And as you can see here, this is the phone drawer, because I actually passed in first the phone drawer. So by polymorphism, it immediately has been casted, quote unquote, casted, right? into this. So right now, if I hit F11 again, and F11 again, it will jump into here, the phone drawer. And right now it will do the printing. And F10, we are done. And once I hit F10, which means steps over, right now I get the render, right? And let's do it again. So I hit F5 again, or sorry, F10. I need to select my thing first. So F10. And right now it's actually returning back because it's done with executing the function or the method. And then we move on. So we draw the line. So if I hit F10 over this one, we get the line, right? And then we move on. Oh, actually, right now I stepped over this thing, projecting in shopping mall. But let's step into the next one. So this, hang on. So this, and then F11. And right now it took me to the chess drawer again. But right now, let's say that this is going to be the 3D projection, as you can see. F11, F11, and then it took me to the 3D projection, right? Then another F11, F11. And yeah, actually, I don't need to step into the thing. So F10, and then F10, F10. And right now we got our rendering done. Okay, render board in 3D. So at the end of the day, the chess game, as a contract, it actually received a contract, or actually received an object that implements a certain contract to be drawn on the screen. Depending on the implementation, you can do whatever you want, right? You can actually go wild with this. In fact, I think there was actually console.color. Gonna be dot red, for example, or not the foreground. What was the text color? I think. There was a text color actually you can change in the console. I just cannot remember anymore. Hang on. Whoa. Sorry. I think it was the foreground indeed. Yeah. So let's say this is red dot foreground indeed, foreground. And this is going to be, because the projector can only project hang on, let me just keep the chat on. And this is going to be, oh, let me put this down. And this is going to be, let's say, green. And because the screen is dark of the console, I'm just going to put here, not blue, but maybe cyan. Okay. And then I hit Control F5 or F5, whatever, Control F5. And as you can see here, right now I'm rendering in 3 different colors, right? I'm saying 3 different colors, but right now you have this 2D on the phone, projecting in the shopping mall, which only accepts green color for some crazy reason, and then you have the cyan one. Now, obviously, this is a more like a state machine, so the console color of the text color of the console is going to be set to the last color you say so. So you have, I think, afterwards you say console.reset color, I think. So this is one here, and this is one there, just in case, just to have a cleaner code. And here's another one. And then Control F5, and right now you should be having press any key to continue to be white, right? And even the lines right now are actually white, if you noticed. So yeah. Okay. Now, while I actually look up the ASCII character a bit, because honestly, like, I know that it's possible, it just escaped me for some reason. Until I find this, can you please, if you have any questions, please shoot them now. Any questions?
Yeah, I have one question.
Yeah.
It's about the marker interfaces. So is the marker interface just an empty interface? Or
Yes, it's an empty interface. That's why it's called the marker interface or marking interface.
oh, and the purpose of having an empty interface is what?
Is to how can I put this? Let me think. I mean, marker interfaces are used to let me. I'm trying to think of an example right now. A marker interface, which is a bad idea generally in design patterns, but let's say that you needed to use this. You will need to use this if you would like to have. Let's say for the sake of the argument. And I think I'm going to spoil .NET here for a minute, but I hope that I can do. And I need to eliminate this. This cannot be here. None of this has to be here. And I hope that ILS doesn't exist in the system. Perfect. Okay. And let's say, I mean, this is not even implemented in C#, but let's say you have an interface called collection, iCollection, which will also exist in .NET. But again, I'm just trying to give an example here that might be a stupid one. Hopefully it will explain what I'm doing. Okay, so what could happen is you could be doing something like this. IQ, whatever. So iCollection. Okay. So right now, what I have done here is I made an interface, which has become a marker interface. And right now, what I can do with this is that I can have, let's say, a class that when it accepts something, it will accept something like this, void something crazy, and then you say iCollection. And what's going to happen here is right. So let it be internal for now. So internal means it's going to be visible within the namespace, and it's not accessible outside of the namespace. I just put it as an internal, so I don't want to have any conflicts anywhere, so I can compile this. And and this is the problem right now. You cannot actually use this per se very much, but you actually have you can successfully do something like this. So public class test 1 is going to implement iList, which has, for example, void do list. Okay, and this one has void do queue. Okay, and then what's going to happen here is, this is why actually it's not useful at all. Or actually it's almost, but not a good idea pretty much. A public class test 2, and then it implements, this is not iList, it should be implementing, yeah, this is iList, right, and this is IQ. And then you could have something like this. I'm not going to run the code, so that's why it will not do this. But right now, what I can do is somewhere down in the void main, I can do something like this. I can say, where did I write this actually? So Okay, so chess game. Let me just get rid of this for a second. So let me just. So chess game, or sorry, chess dot something crazy. And you see it's internal and they put the heart sign on it for some reason. And as you can see here, it accepts I collection, right? And right now I can have here new test 1 and it will work. And then you have chess dot something crazy new test 2 and it will work. Both of these guys are having completely two different interfaces. So IQ is different from iList. They have two different methods. But this marking interface, let's say, which they both implement, they are right now like the same by polymorphism. So at the end of the day, you can actually do such a move. Again, it's a design decision. It's usually frowned upon. I haven't met anybody who likes this. But sometimes, but actually, if you're gonna use it responsibly. Let's say, you can Google marking interfaces in C# and you can see examples of that. But practically speaking, this is what can be possibly done with it. Does this make any sense?
Yeah, it does. And one more question.
Mm-hmm. Yeah.
I was reading the documentation that you sent in the chat, and I'm just not familiar with the one term that's constantly used, and that is managed code. I don't know what that actually refers to, so if you could explain that.
Yeah, sure. A managed code is... hang on. So so C++ is unmanaged code. Means that you don't have a runtime, that a common language runtime. You don't have a CLR. You don't have a garbage collector. You don't have somebody. You don't have a program that does memory management for you. So managed programming languages are programming languages. They have a runtime, that they have garbage collector. They manage the memory for you. This is what the managed code is. Unmanaged code is the code that actually using pointers. Well, both of them are using pointers, but let's say the code which you have to handle memory management by your hand. That's why there are no program to manage it for you. That's why it's called unmanaged. Okay? Make sense?
Okay, thank you, great.
Okay. All right. And that's it. This is it, I think. I don't have any... this right now regarding the interfaces. Let me just check my notes here. Did I miss anything? So just to be like, just to recap here, we mentioned lowering, garbage collection, constant read-only inheritance, abstract classes, virtual and abstract, interfaces, the very simplified version of it, because interfaces, the more complex version of it is, or complex. The interesting special case of interfaces is dependency injection, which Dennis, I think, have mentioned already. So just an FYI, let me just remove this. You're gonna see actually, like, you need to try this at home, study it more, try to find problems that you can solve it using interfaces, so you could have a better feeling for it. Once you have a better feeling for it, you will totally understand how dependency injection works, okay? Because it really relies on understanding how interfaces actually work, along with polymorphism. Okay. All right, so I think this is pretty much it. I could actually like Control A, and let me just write here such the P, K, Q, and I'll just simply Control A this, and let me save. And I will paste that code right here. So let me see, code snippet, and I will just simply Control V that. And this is, oh, there's syntax highlighting and everything. Cool, C#. And this is like for study and testing, or let me write it. So, and there you go. Right now I've sent you the source code in the chat. Like it's just copy pasted the whole thing. Again, please understand that we are actually learning here. So the code is not optimal by any means. We are just demonstrating certain things and how to use certain syntax in the language. So it can be more optimized. It can be done much better. Just for example, this drawing code is not a responsibility of a chess game. It's actually a responsibility of, for example, public class chess game renderer. Right? That actually draws a chess game. So it takes, for example, let's say you can have two options. Either you assign to it a chess game, or you can pass it as a parameter if you want to. But regardless of that, it's draw the game. You can do that, for example. I mean, the design can be argued against, but in any case, this is the better way of doing it. So right now, if you like a little bit better, because right now your renderer's job is to call the rendering of each one of those guys. So at the end of the day, you don't have draw. What you can do is have a var renderer equals to new chess game renderer, and then you can say renderer dot draw, and then you pass to it these stuff. Hang on, let's actually modify this even better. Oh, not this. I need this, and it should be actually take a chess game, gonna be game equals to game. So let's make it just a tiny bit better, just a tiny bit. And then I'm just gonna pass to it chess. And right now, I can eliminate all this. I don't need this. And shift enter. And might be, this is gonna be renderer, and this is gonna be renderer. There we go. And right now, it should be, I mean, it will work, again, the same. It just, I applied the single responsibility principle, which is the chess game is actually taking care of the game rules, the illegal moves, the board, and even the board can be extracted in its own classes, because the board is the chess game should be governing the rules and stuff, but the board should be taking care of itself. But it's another story. I will not complicate this any further. But in any way, just this game, it just holds the data and everything regarding the game. How the game is going to be rendered, it has to be extracted out. So right now, the chess game doesn't know anything about drawing. It doesn't know it can be drawn even. For all what it's worth, right now, you can integrate this class into a robot, and the robot will move a hand, right? It will not care about right now rendering or anything. This guy, however, is actually game renderer. If you are one of those people who are interested in chess, you have actually electrical chessboards, electromechanical chessboards, where it actually moves the pieces for you. Now, this is obviously an expensive thing, but you can actually right now have a Raspberry Pi controlling some robotic arms that it just simply have, and the implementation underneath could be having like a public class. Right now, it's not going to be renderer. It's going to be like mover or something like that. And right now, your chess is going to be projected or moved on a physical table, let's say. So chess physical table, let's say. And right now, you can write the handling for robotic arms, all these stuff in here, right? And that's pretty much it. So right now, you actually separated the logic from the actual implementation of how you're going to show the chess game, whether on a physical board or on a screen, or a phone screen or a projector or a 3D projection thing. Yeah. We mixed a little bit of software engineering and learning how to do syntax in C#. But I think when we mention interfaces, when we talk about them, it's actually like, yeah, it's a language construct, but you need to understand like how to utilize them. So that's why we cross over to software engineering and ADS. All right. Any further questions? Oh, let me paste the updated code for you. Insert code snippet. Slightly better code. Just put this as C# again, and slightly better. There you go. All right. This is it then. I hope that you enjoyed the ride, and I'll stop the recording then.